What's up, everyone? Welcome back to Better Biomed. Today I am going to try and solve a problem that we have had in many hospitals here in Houston, probably all around the country, if not the world. That is the failure of the GE Panda scales. They're failing, and they're failing all over the place. And the craziest thing is they are charging OEM $3,000, pretty much $3,000 for these scales. That's insane. I think it's going to be even more insane when we take it apart and figure out what's inside the scale. I'm kind of curious, very curious, in fact. So, guys, that's what we're going to do. We're going to take this guy apart, figure out what's going on, and I can maybe see something already. I've got this cord. I don't know, let's see if I can get you guys a good angle. Look at how this cord is being stressed right here. See that? Look at that crazy angle. It's like they yanked on it and then they tightened it down while it's being yanked. That is not good for the longevity of any cable. That looks like absolute garbage. That's probably not the problem. I'm expecting it to be in the load cells, but we're going to find out together. Coming up next, right here, Better Biomed. Okay, folks, I got the GE Panda scale right here, and man, I don't know how complex it is to take this thing apart, and I don't even know why it's failing. I know that so many of them are failing calibration, and here is what I tell people if they fail calibration. So normally when we calibrate, we put the 5 kilogram in the center, and then you run it. And if it gives you a stable reading, then you are good. But what I'm telling people now is redo the calibration 5 different times. Put the weight in this corner, put the weight in this corner, then over here, and move that weight around and see if it fails at one of the corners and not at the others. More so, when you calibrate a scale by moving a weight around, what you're doing is you're adjusting the gain on these load cells. So what I would assume you're doing is resetting the gain more specific to the defective or problematic strained load cell. So now maybe when you do the 5th calibration with the weight in the middle, now it's going to pass. I've seen it on other devices. I don't know if it works on this one, but that's certainly what I would try if you have a scale that is failing. But guys, that's not why we're here. We're here because we're going to take this bad boy apart and figure out why is it $3,000. $3,000 scale. Now, many of these devices that I have checked all over the place, many different hospitals, they are just straight up not calibrated. They're way off. Why are they so far off? Are Biomeds not calibrating these on their own? So I'm checking right here because sometimes these Limo style round connectors, the rear end, not necessarily on the scales, but on other devices, this part here gets loose and then the cable will want to spin, so it breaks conductors. I don't think that that is the issue on this one. Okay, so we got load cells here, we got load cells over here, and we got a little junction box over here that looks pretty fun. Matter of fact, it looks so fun that I'm going to take it apart. I'm breaking one of my major rules, folks, is to not flat surface fasteners. Here we go. Come on. $3,000 scale. Must be one heck of a scale, right? Okay, we have a breakout by Falcon. Interesting thing here is I believe we can do a RS-232. I believe, maybe not. There are some headers for programming the chip. Boop, boop. It's probably just going to get blurrier. Yep. So you got the two analog signals come in over here on these headers, and then this board here translates them into a digital signal, and it goes out on your line. So my first guess is, are these connectors loose? No, they're not really loose. Everything's tight. It looks like this board is conformally coated because it is very shiny and it looks like all the components are covered. That's probably pretty smart because it's sitting in a low point, and if any fluids tend to spill, I don't know about you guys, but fluids love to go to low points, so that kind of protects the circuitry. The cables look pretty good. Now, I'm not going to do a continuity check right now between here and here, but that would certainly be easy to do at this point. My guess is that we just have some old and strained strain reliefs. They have one job, that is to be strained, and I think they've done so. Oh my gosh, those are tight. Oh my gosh. This scale here was donated to me by a hospital that has had to put 5 or 6 of these scales in their fleet just in the last couple weeks, and that is amazing. It's staggering, and it's so expensive. So expensive, folks. Wow, those are on so tight. And I'm not saying Loctite on them. They're just cranking them down, giving it a good hot supper. Okay. All right, so there's a shim. What? There's a shim down at the one end. And let's see. It's really interesting because they have their calibrated values written on the outside. So these are shekel OIML-C3 load cells. So these look like they're generic load cells. It's probably something that you can buy on the open market. And it's crazy because it says the output in millivolts per volt. So it says this one here, output to 1604 millivolts divided by volts. Interesting. And then this one over here says 1606 millivolts per volt. So I'm going to have to study up on what that means for load cells because I don't know how they're rated. But I don't see any physical damage on these guys. It's just, well, the epoxy on both of them is cracking just like this. Yeah. It's really more of a silicone than an epoxy, I think. Yeah, I don't know. It feels like a really soft durometer like silicone, but it's very rigid right here in the middle like an epoxy. So let's just say it's an epoxy. Okay, so I would be very curious if these are repairable. Reason being is you have these little connectors right here, which you can buy. All right, you can get these little connectors, and you would just repin it, and then you would have to do a calibration. And I'm guessing that this guy right here is going to set your voltage to your load cells. So this is how you calibrate the voltage, probably according to their specs. You're probably going to have to measure that right here. And then the 16.04, I don't know if that has to be programmed or not. That's interesting. I'll have to look that up. But my guess is that these things right here, you buy them pretty close to the same value. It looks like they're floating around 16 millivolts per volt. And you're going to put it in, repin it, and then you're going to do your calibration. that is my guess of what happens here. I'm going to do some more research after this video. And I'm going to check up on this guy and this guy so I can get a part price. And then the only other thing that would really even make a difference would be this board over here by Falcon. And let's see, I don't see a part number on it. It says FAL, FALGEUS 2. And I've got 11782 underneath it. Interesting. Kind of a primitive device if you think about it. So it takes an analog signal from this guy and this guy, and it converts that against probably a known table of values, and it outputs a digital signal to this guy where it's read by the computer. Okay? So when you are putting a 5 kilogram weight on it, I can see already that it doesn't matter if it's in this corner, in this corner, this corner, and this corner, because there's only 2 load cells. All right, I was expecting 4 because it's a $3,000 scale. It's got 2 load cells. So you would move the weight up here in this corner, then you would move it down here. So move the weight from one side to the other. You've only got 2 values that you can change. So that would be 3 calibrations. 1 over here, 1 back here, 1 in the middle. Check it out and see if it clears. You're good. Now, the other thing that you should always check on these scales is we've got rubber standoffs. You want to make sure that these here are not degrading. And you want to make sure that your fasteners are all tight. Because if your fasteners aren't tight or these rubbers are degrading, then your bed is not going to sit on there flat. And you're probably going to come up with some load errors. And that's it. Fascinating. You never know what you're going to run into. Anyway, guys, that is a teardown of a GE Panda / Giraffe bed scale. And believe it or not, it does not look that complex. I'm going to check and see if we can get some replacement parts and maybe test and see if we can get one of these to calibrate normally. Thanks for watching, folks.
If you enjoyed this video, don't forget to give it a thumbs up and subscribe for more content. I'd love to hear your thoughts, so drop a comment below with what you'd like to see in future videos.